Uh, Hello guys, good evening. How are you all? Hello guys, how are you all? Good evening to all. Good evening guys, good evening. Priyanka Jan, you will receive it. Don't worry. If you guys haven't received it, you will receive it. Basically, I forgot to share it with the team, but today I'll be just going to share it. Really sorry about it. So by like today evening, you'll be going to get all the notes that we have discussed from the day one to the last day. Okay, I was like a little bit busy over that time. That's why. Okay. Video link, like video is already there, guys. I think. Okay. Video is basically already there, each and every this thing. So, like, what kind of a video link you guys are looking for? Yeah, good evening, guys. Okay, okay. Yeah. So, what we'll be basically going to do today, we'll be simply going to, let me just share my screen first of all. Let me just share my screen. Where is it? Let me just share my screen over here. Okay. All right. So guys, just see a little bit these things we have already seen, but today we'll be basically going to cover machine learning part. Okay. Now, so for machine learning, we have something known as sklearn. How many of you are aware about sklearn? Guys, tell me, are you guys aware about sklearn? What sklearn is? Okay. So let us just say in machine learning, first, all right. Okay. 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 So guys, just tell me one thing. In machine learning, do you guys know some algorithms? Like what are basically the algorithms that are there in machine learning that we'll be going to work with? That is just a linear regression, logistic regression like this. Do you guys have any kind of a idea on it? Okay, all right. So just see guys. One thing we'll be basically going to do over here is one thing we'll be basically going to do over here that we'll be basically going to this sklearn library that you'll be basically able to see. This is the library which we'll be basically going to use for the this thing for the machine learning part. Let's just say in machine learning we have different algorithms. If I just open my screen over here in the day one, if you remember, we have basically seen this thing, that this is basically your data set over here. Now just see this thing, name, class, gender, marks are basically there. So if a student will going to fail it or if a student will going to pass it. So this is basically known as a classification problem, right? But if we basically have to predict marks like this 70, 30, 90, then we'll be going to go with learning algorithms. Okay, I hope you guys remember it. Okay, this thing. So these are basically two tasks that are there. That is your regression, and one is basically your classification. Okay, now what we'll be going to do over here, we have multiple models. Let us just say if I will just simply going to talk about regression. Regression is basically the task that we'll be going to work with. So in regression, we basically have, just see, linear regression. The second we basically have Let us just say multiple with respect to regression only. We basically have decision tree regressor. Similarly, we have random forest regressor. Okay, and in classification, same model is basically there, but the name is basically going to change over here. The name is basically going to change. So let us just say the first one will basically going to be logistic regression. The second one will basically going to be decision tree classifier. The third one will basically going to be random forest classifier. Okay, so these are just the demo that I have basically mentioned over here, that these are some basic models that we'll be going to use in the regression and in the classification part. But the main things that come over here is like how we can basically use these things. Okay, that is the main thing, like how we'll be going to like how we'll be going to use it, and how these things are basically working internally, and what kind of a problem they'll be basically going to solve over here. That is the main thing, right? So these things we'll be simply going to cover in today's session only, where I'll be just going to give you a little bit overview of machine learning, what machine learning is, and what kind of algorithms you basically have over here. Okay, yeah. So let us just say if we have these things. So this is basically my classification. Like supervised learning, we basically have, I have told you, like we have supervised learning and unsupervised learning is basically there. Okay. Now, if I basically want to do one thing, I basically want to do linear regression over here. Okay, or let's just say logistic regression I basically want to do over here. So what I'll be just going to do, these are basically nothing but these are basically your algorithms only. The example I have already given you, that if you want to basically predict whether the student will going to pass the exam or not, okay, whether the student will basically going to get this kind of a marks or not, this thing you basically have to this thing you basically have to predict. So how you'll be able to do it? Okay, how you'll be able to do it, this is the main thing, right? So just give me 1 second. So I'll be just going to open my Google Colab over here, like one more new notebook I'll be just going to open it over here, so you guys will be able to understand how these things are basically working. Like if I just talk about working, the working is really different in this thing. Okay, the working is like really different over here. So let's just try to understand how these things are basically working. So over here, I'll be just simply going to connect my Google Colab, and I'll be just going to paste this similar kind of a data set. So what is this thing? We have name, okay, we have class, we have gender, and we basically have marks over here. Okay. And on this thing, we'll be basically going to build a linear regression model. And how we'll be basically going to do the same thing. So let's just go and look into it, how these things are basically going to work. So over here, I'll be simply going to execute it first of all, and it will going to print the df for me. If you'll be just going to remove this print one over here, so you'll be easily able to see the data frame in a more structured way, like this. Okay, now over here I'll be simply going to mention the code that we'll be going to work with. So over here it is like nothing. What I'll be just going to do, I'll be simply going to execute it. Okay, now let us just say right now we are only using one thing. We are only using like gender will be there. On the basis of gender, we'll be basically going to predict what kind of a marks a student will basically going to get. So if I basically have to do this thing, let us just say I wanted to find out model dot, if I'm basically doing these things, you don't have to understand the code for now. If I'm doing model dot predict 0. Okay. All right. Okay. So over here it is saying that if the gender is zero, zero is like what? Let's just say for male. So this is the marks out of 100 a student will going to get. If it is a female, then this is the marks that they'll be going to get. But what we can do, we can make it more meaningful. Okay. So let us just say what we'll be going to do. Uh, hmm, okay. So over here, we'll be basically going to create two new columns, which will be like study hours and play hours. So on the basis of these things, we'll be simply going to decide that if a student is studying for this much of hours and if a student is basically playing for this much of hours. So what will be the impact on the result? So let us just do one thing. Let us just replace this kind of a data set and let us just do. So it will like create a more meaningful information for you. So just see this thing. Let's just say Satyam is there. Study hour, if we just talk about, that is 5. Play hour is basically 2. Marks that Satyam is basically getting, that is 70. Now, Harshit is basically studying only for 2 hours and he is basically playing for 5 hours. So for sure he will going to get this thing. Okay. Is this data good? Is this data set good for you guys? What do you think? Or should I like, yes, you will be going to get the code. But guys, should I like make this data set more easier or something that you will be basically able to understand? Or this is good. What do you think? Okay. Okay. You will be going to get the code. Don't worry. That's good. Okay. So after that, what we'll be basically going to do over here, like this is basically the kind of data set that I basically have over here. Now on this data set, we'll be simply going to predict it. Now let us just say this will be basically going to change like this. And now we are saying, don't try to understand the code for now. I'll be going to explain you. Now we have study hours and we have play hours and we basically have marks. So what we are saying, I will pass you study hours and play hours, or let us just do one thing. Don't focus on this thing. Now I'll be, and don't focus on these things. What I'm basically doing, just remember one thing, that I'm calling some kind of a line of code. And what I'm doing, I'm basically saying, what if a student will study for 1 hour and play for 5 hours? What is the marks that a student will going to get? Model is saying 41. Okay, if I just increase this thing, I think the second one is play hours here. Then let us just say what we'll be going to get, 16. That means if your play hours are increasing, so it will going to impact your marks. Or we can like print it in a more good way. Let us just say uh, result and result. Okay. Mhm. Just give me 1 second. Just give me 1 second, guys. 1 second. All right. So, really sorry, guys. So over here, you will be basically able to see one thing that I can basically say. Just 1 second. Yeah. Over here, you will be like able to see one thing, that if the basically study hours are basically increasing, so at that time, what is basically happening? At that time, the students will going to get a good marks. But if a student is basically more focusing on the play part, so for sure in the study he is basically not going to perform well. So like that is the main thing over here. So this is what we are even trying to predict over here. Same thing. So this is what known as, this is basically known as your regression part. Now let us just say if I'll be simply going to increase this thing, let's just say if I'll be just simply going to give you the result, how the result will basically going to look like. Okay, result is basically what? Okay, leave it. So let us just say I'll be just going to say if someone is studying for 5 hours and playing for 1 hour, so what should be the result? So now it will going to give me that student will going to score 73 marks out of 100. But what if a student is studying for 8 hours and playing for 0 hours? Or let us just say same thing, 5 hours is studying, 0 hour playing. Now let us just see previously it was 73, now it is 78. But if we'll be going to increase the study hours, just see it is 84. Let us just try to increase 1, that is 79 again. If I'll be going to increase it to 3, so from 82 or 83 it's been like now at 69. Okay, okay, Shri was Gopinath, just see one thing. Companies are hiring for freshers also. So at that time, you should be like good at coding. It's not like that you should be a pro in coding or something is basically there, right? But the main thing over here is that I can basically say, over here, you know what coding is basically. A little bit DSA you should know, not that much, but how your log building skills should be really good. And if I just basically, yes, and if I basically just talk about one thing, you should even have little bit information about the machine learning, deep learning, natural language processing. And these days, most of the companies are even focusing on the generative AI part. So let us just say in machine learning, you should know little bit algorithms are same that I'm explaining you. What is a linear regression, logistic regression, k nearest neighbor, SVM? These are these things. What is overfitting? What is underfitting in machine learning? Okay, these are the basically the things that you should basically know. Now, if we just talk about how this thing is working, so over here you will be able to see that this linear regression model is there that we are using. Now if I just going to give you a linear regression model overview that how this is basically working, so for that I'll be simply going to a little bit overview I'll be basically going to give over here. So what I'll be just going to do, I'll be just going to copy the image address and I'll be simply going to paste it over here and I'll be just going to click enter. Now just see what it does is, let us just say this is basically your study hours. On the y-axis, whatever you will be able to see, these are your study hours. And on the x-axis, whatever you will be able to see, these are basically your marks. Okay, now just see, these are your data points. Let's just say if this is basically your data point, let me just do one thing. Yeah, let us just say if this is basically your data point, this one, right? So we are saying like someone is studying for 7 hours. So let us just say this value is basically going to represent to, let us just say 80 marks. Okay, 80 marks. Okay, let's just forget these things now. Okay, so this is saying these things. But what my model is basically going to say on the basis of the predicted value, what my model used to do, it basically used to draw one straight line. These blue points that you will be able to see, these are your actual data. All right, so what it is saying that if someone is basically studying for 7 hours, so he will be able to get 80 marks. But what my model is doing, if it has basically drawn a straight line like this, that simply means that this was your predicted, this was your actual point. Okay, that means this is your actual data, but your model saying no, the predicted one is this thing. So the difference between these two, this straight line and this blue dot, is basically known as error. Like this is basically known as error. Okay. Are you guys understanding it? So this red straight line is basically nothing. This is the predicted line. The same code that we have basically seen over here. Just look over here. the same code that we have seen over here. This thing over here, we are basically saying where it has gone. Okay, I think this, okay, this was the one. Yeah. So if someone is studying for 7 hours and playing for 1 hour, so for sure he or she will be easily able to score more than 85 marks. But model is saying no, it should be 95. So if I just do one thing, 85 minus 79.26, so this much error is basically there between the, so this is your predicted value. So this predicted value is nothing but this is your red line. This is your, this red line. And this 85, if I'm saying someone is studying for 7 hours, he or she will easily able to get 85 marks. So that is your, this blue dot. Okay. So if the actual value is 85 and my model is saying no, that is 79. So this is the error between it. Because if you consider any machine learning model, any artificial intelligence model, they will never give you accurate information. The accuracy will not always 100%. It will always, it will almost be equal to 80%, 85%, or max to max 90%, not more than 90% in real life. And 80% is really sufficient. Any kind of a confusion till now, guys, with respect to linear regression? Just 1 second, guys. Any kind of a confusion till now, guys? No, no, no. Abhi, Dhan, just see. If you can get even more than 90% accuracy, that is not like that. And it will not be a overfitting case. You can even get 95% accuracy. But these cases are very rare. Because most of the time you will be just going to get the accuracy between this thing, between 80 to 85 or max to max 90. All right, cool. Now, just see one thing, guys, what we'll be going to do. Now, let us just say you got this error. So how you will be going to solve, how you will be going to get, what is your total error that you are getting? Because I know that this red line is basically there and this blue are basically predicted dots, but I have to compare error. Okay, what is my error? If I have created 5 models, so which model is having the least error? So can anyone help me in this thing? How I'll be able to find this thing? Which is not visible? Yes, MSc, MAE. Yes, error will not always give you, with the help of error, you like, with the help of just one matrix, you cannot define your model that is it a bad model or it is a good model. No, Muthana, it is not like that. Companies are even hiring for freshers also. Now, just see one thing. Shivam, what I was asking is how to evaluate your model, that if you have trained 5 models, so which model is performing well? So that we have performance matrices. So performance matrices, if we just talk about, so we have multiple matrices. We have MSE, we have MAE, we have RMSE, we have R 2 score, we have adjusted R2. So MSE, MAE, RMSE is there. So let us just see MSE first. Mean square error scalar. Just see all the code that I'll be just going to do over here. That is already present on the official documentation. It's not like that something I'm doing from my own. So let's just copy this thing. Scalar.matrix. This thing I'll be just going to copy from the official documentation. These are the evaluation matrices. So first I have to import it from scalar this thing. Import mean square error, run it, mean square error, and then just what it is saying, just see what it is saying. First mention the y true, then y predicted. So it is saying first try to mention the true value, then mention the predicted value. So let us just say my true value was this thing and my predicted value was this thing. Okay, it should be in expected array. Okay, both should be in array, sorry. Yes. So right now it is saying the error is 32. How 32? Because this is the mean square error. If you just multiply it, you will be able to get this particular value. Okay. So what it does is, it basically used to tell you the error. Let us just say if you have another model who is predicting things like this. Now you tell me, who is basically predicting things like this. Now you tell me, if you have two models, one is having this error. Let us just say model 2 is having this error. Model 1 is having this error. Now tell me which model you will select. That you will be going to work with this model in future. Which model you will be going to select? From the model 1 and from the model 2. 2. Okay. What about others? One. Okay. Why one? Because 2 is having very less error. Okay. So we should go with 2 only, guys. Okay. Yes. So these are the, now let us just say I have told you this is square error. We have one more thing, MAE. Okay. Now let us just search MAE over here. Mean absolute error. And this is again the same code that they have given. If you'll be just going to scroll down a little bit, you'll be able to see that this is the code that they are using. So let us just paste it over here. Mean, this you have to import like this. Mean square error we have imported. Now mean absolute error will be going to import. And these are going to be my particular values. So just see this thing. This is one error. And if I just copy it and if I just paste it here and instead of I should write 85. So this is the error. So we have to compare with all of the matrices, like what is the majority vote saying? Like multiple matrices will be going to use, and whichever matrix is going to give me a major vote that okay, this is having a less error, so I'll be just going to pick up that particular model. Any kind of a confusion till now, guys? Do you guys have any kind of a confusion till now? Or the things that I have explained you, are these clear or not? Okay, okay. So this is what your machine. These are too much things. Okay, shift sublog. Just see, these are not too much. Why someone will going to pay you a high package or a high this thing if you'll be not going to learn these things? Okay, so things are not that much hard. What you have to do is you just have to give your time, because this is like nothing. You have to learn these things in very much detail. Okay, only then you will be able to get a job in data science. Yes, we will. Yes, after doing one project, you will be easily going to remember these things. Okay. Pratik, how much statistics is needed? Just a little bit part. Statistics is basically like just learn about what is normal distribution, standard distribution is basically there. T test is basically there, Z test is there, and over test is there. So all the tests try to cover these things. Then after that, what is normalization, standardization, and I can basically say what is central limit theorem. A little bit, a overview, just have it. Okay. Yeah. A very simple one, guys. A very simple one, Pratik. Now, similarly, let us just take an example for classification. Now, just see this thing. Now we have a data set. Let's just print it like this. Now we have a data set which will just going to have, let's just say, marks are there, pass and fail is basically there. Let's just say if the marks are less, the student will basically going to fail or student will basically going to pass it. This we just have to predict for now. Okay, so let's just say for now we have this code where we are basically saying study hour and play hour, and the result will be pass and fail. So let's just say now we will be going to predict these things. Model dot predict, and we'll be simply going to do study hours was basically there. I think study hours and play hours. So if someone is studying for 5 hours and playing for 1 hour, what should be the result? uh, Take two questions, but three were given. Okay. Okay. It should be like this thing. Okay. So they are saying that student will be able to pass the exam. What if it is opposite? That is zero. What if someone is playing for 5 hours and studying for 5 hours? It is one. Now it is not showing you that what this thing, what will be your score. Now the model that we have trained, this is just going to basically tell me whether someone will going to fail or this thing, whether someone will basically going to pass the exam or not. Okay, so this thing is known as classification. Now for the linear, for the this thing regression part, we have used linear regression. Just see this thing, like linear regression was there, and where we was like predicting if someone is studying for this thing, playing for this thing, this is the marks that we will be going to get. Now for the classification, what we have did, we are basically using something known as logistic regression. All right, and we are basically doing a passing a value and it is giving us 0 or 1. Now guys, the scenarios will be different. You guys might be thinking, okay, so we should like go with marks. What I feel is marks are good. If I'll be able to get, okay, this is the marks that a student will going to get, I'll be easily able to know, okay, whether the student will going to fail the exam or not. But just see one thing, guys, this is a good confusion that you guys are having if you have this kind of a confusion. But one thing is there, it all depends on the company. Let us just try to relate it with a real life example. If an insurance company is there who just wanted to know whether we should give an insurance to this person or not, based on their credit score, maybe on their past loan history or something. Okay, what if some company wants to predict the sales? So at that time, you'll be going to use regression. So both of the things depends on the scenario. I hope I am able to make you understand how things are working. Do you have any kind of a confusion till now, guys? Now let's just look into little bit of logistic regression. Guys, are we clear till now? Can I get a quick confirmation? Okay. So this is a logistic regression. What it says is you will be just going to pass it a value and it will pass to this curve. This curve is basically known as sigmoid, right? And when if you'll be going to get a value, this is basically your this thing. Okay. The y is basically having a range of, let me just show you this thing. This is having a this thing of 0.5. If the value is greater than 0.5, it will going to say the student will be able to pass the exam. But if the value is less than 0.5, it will going to tell you that no, the student will not going to pass the exam. Understood? This is what sigmoid is for now. Shiv Sablok, I was basically saying this thing that if we are doing classification, you guys might have a confusion that why are we not using a classification? Because we are just predicting whether a student will going to fail the exam or pass the exam. But if we'll be able to know what marks a student is getting, at that time we'll be easily able to know whether the student will going to pass or fail. So why we are using classification? But over here, the example that I have given you just to show you how classification is looking like and how regression is basically looking like. This is what I was talking about. Now, let us just say, okay, in regression, what we was doing, if we have to compare the error, we was using this mean square error and mean absolute error. But how do we compare it in this thing? How do we compare it in classification? Let us just say if I'll be going to use this thing in classification and I'll be just going to mention that the actual value was that 0, that student will going to fail the exam. But my model is saying student will going to pass the exam. So how it will look like? It is saying 1. That means it is 100% error. Okay. So for that, we have some different matrices. These are like accuracy score, classification report. Okay. Let us just say if you have basically predicted, let's just consider one thing. If I have predicted this thing, okay, and this is my actual value, y. Now just try to understand. Over here, I'm saying this one record is representing student will going to pass the exam. 1 is pass, 0 is fail, 1 is pass, 0 is fail, this thing. But in actual, okay, but in actual, it was somewhere like this, that this one was 0 and this one was 0 was 1. So how many values we have misclassified? Just tell me in the chat, guys. What do you think? How many values we have misclassified? Can I say 2? Now I want to compare what is the accuracy of my model. So for that, I'll be just going to use this accuracy score. And over here, I'll be just simply going to pass my this thing. that these are my actual values and these are my predicted values. It will going to tell you your model accuracy is 66. But what if I'll be just going to mention one over here? Now it is saying 83. That means from this only one value we have misclassified and rest of the values are correct. So this is known as accuracy score. So in classification, we use accuracy. Are you guys able to understand it? Do you guys have any kind of a confusion till now, guys? Can I quickly get a confirmation? Can I quickly get a confirmation about it? No confusion? Okay, Priyanka, what I was basically saying over here is, let's just say if we'll be going to use a regression. So at that time, we'll be going to use mean square error for the evaluation matrices, because in regression, we use these things. For different scenarios, we have different evaluation matrices. But if we are using classification, so at that time, we'll be going to use this accuracy score. So it is basically like this thing, that my actual value, this is like, just see, this is my actual value. Forgot everything. The one record that I was having, what kind of a record? Let us just say my data frame. This is my data frame. When I'm saying my study hours are 5 and play hours are 2, that means a student will be able to pass the exam. Okay, I'm saying my study hours are 10 and playing hour is 2. Student will be able to pass the exam. This is the label with respect to it. And 0 is basically what? Where students are playing for 5 hours and studying for 1 hour. Okay, so this is my actual labels. Actual labels means these values, pass and fail values. So with respect to each and every record, I have just mentioned these values. Okay, but my model is saying over here that if a student is basically studying over here, if I'm saying a student is studying for 3 hours and playing for 1 hour, he or she will also be able to pass the exam. But the model is saying no. So this is the wrong prediction that my model have did. So if I basically have to check how my model is performing, so at that time, I'll be simply going to use accuracy score. This is what I was explaining. Yes, if all values are same, it will going to show you that your accuracy is 100%. This is what the coding of model looks like. Just see, I have imported a logic regression, okay, from sklearn.linear model that is already mentioned on the official documentation. I like, this is the same code that they have given over there. After that, what we have did, we have like did one thing. We have basically passed my data set over here. That is nothing but your this thing. Okay, just see, one thing is also there, that is train test split. Over here we have just passed x comma y. X is basically my the independent variables and y is my dependent variable. So if I just compare x test, what is x test and how does it look like? So we are saying basically x test, x train is this thing. If someone study for 4 hours, play 4 hours, what should be the result? So the result is stored in y train. Just see, with respect to one record, the first record, the result is 1 with 1, the second one 1, then 0, 1, 1, 1. 0 we are saying for this one. If someone is studying for 3 hours and playing for 5 hours. Okay, so the same thing, like we are passing that you have to learn these things. Study hour, play hour, and you have to predict these labels. So over here, the train test split, this function that we are using, this is basically nothing, but this is just splitting the data set. Let us just say if you are basically doing a revision or something, you are preparing for your exam. Smith, you can build your own model also. but that will be not going to teach over here, because for that your coding skills should really be good. It's just not about learning lists, tuples and all. Okay. Now, so train test split we basically have, so we are just splitting the data set. Let us just say you have 5 units to cover. Okay. So what you will be basically going to do, some like unit you have basically covered and you was basically doing revision and all, but at the end you will be just going to left some part of it, that okay, what I'll be going to do, these are the similar thing, I'll be just going to learn this particular thing, and after it I'll be just simply going to test myself that from these things what I have learned. If you will be just going to give a good if you'll be just going to give a correct answer to it, so for sure at that time your preparation was, the preparation that you have did, that was really well. So the same thing we are doing. First we are like training our data set over here with respect to x train and x test, and then we are just predicting it with the unknown data set. What does this thing mean? Like y train we basically have, sorry, x test we basically have. So this was the training. X train was for training. Then we similarly have X test. So over here we only have two records where we'll be going to ask model, if someone will study for 12 hours and play for 0 hour, what should be the result? And if someone will study for 2 hours and play for 5 hours, what should be the result? So let's just compare this thing. How we'll be going to do it? We'll be simply going to do it like model dot predict X test. So it has written two values, that is 1 comma 1. But what was the actual values? The actual values are basically stored in y test. Y basically mean the label. So let us just test the y also over here. But y is saying, just saying, y is saying basically that if someone is studying for 12 hours, playing for 0 hours, he will going to pass the exam, he or she. But if someone is studying for 2 hours and playing for 5 hours, he or she will going to fail the exam. But model is saying both one, just to compare it. Okay. Yes, Shri Vikas, what I'll be going to do tomorrow, I'll be just going to introduce you some things like Kaggle, GitHub, and these things. Okay. So at that time, you will be going to get familiar with these things. Okay. If I want to make a audio processing model such as XAM app, which app should I like focus on? So the first thing that you have to do over here is you basically have to build a speech to text model. Okay. Only after that you will be able to do. So what they are basically doing, first they are like converting it into speech to text, and after that the text that you are basically getting, the text that you are basically getting from the this thing, the audio or maybe something, they are just comparing it, the words. If it is getting matched with the similar kind of word, then it is basically returning you, okay, this is that particular sound. Got it? Okay. Prinka Justi, even in the starting, I was not very good in Python and all. But one thing is there, you just have to do keep practicing these things. That's it. Just keep doing practice and all, and for sure at the end you will be really good. Okay. Priyanka Jain, just see one thing is basically there. It is like the time that I have given. I have faced a lot of error in my life with like multiple errors with respect to one thing, and I was just searching these errors. So all you have to do is participate in hackathons, participate in Kaggle competition. At that time, you will be like able to know these things. Yes, Rajan, natural language processing is NLP. So at that time, you will be able to improve your skills. All right. Now, one thing is basically there. The same thing that I have basically given you over here. So now we basically have this thing also. Similarly, the logistic regression and linear regression that we have seen, similarly, we have multiple models. You just have to call them like this. That just a logistic regression is basically there. Okay. So how will be basically going to import it? Let me just show you these things. Just it. Logistic regression, decision tree classifier, random forest classifier. So these things that you will be able to see, these are nothing but these are just the models. How like things are basically working in the back end, nothing else. These are just the models, nothing else. Okay. So if I'll be simply going to execute it, like what we are basically doing over here, like one by one, we are like training all of these models over here and we are basically printing the result, nothing else. Okay. We are like doing nothing, but we are just similarly predicting it. Cool. So it will like going to show you, okay, random forest is having accuracy of 0.5, decision tree is having accuracy of 1, that is 100%. Okay, lost regression is having accuracy of 0.5, and support vector machine that is having accuracy of 0.5. So from out of these model, what you have to do each and every time, you have to train multiple models like this. Okay, so you will be like able to know, you will be basically able to know which model is basically performing well and good. Yeah, Rajan, what I can basically do tomorrow, I can introduce these things. I can like mention these things in a pipeline, so you guys will be easily able to understand it. This is what I can do for tomorrow. A small, mini, and good project. I'll be just going to prepare for today only, and I'll be just going to share it with all of you tomorrow. All right, because in 1 hour we can like cover limited things only. Any kind of a confusion till now, guys? Does anyone have any kind of a confusion till now? Okay. I'm just waiting for 1 more minute, guys. If you, yeah, for sure, Vipasha, what I'll be just going to do, I'll be just going to share all the notes today only. Okay, really sorry, I forgot to do these things. Like tomorrow, I will share it. Like today only, I will share it with the Let's Upgrade team, and they'll be just going to upload it. Yeah, yeah, sure, I'll be going to send it. Okay, guys, so I can say this is it for today's session. So thank you very much, guys, for joining the session. This is it for today's session. So, guys, thank you very much. Have a good day, good night, sorry, and take care and keep doing the practice. Okay, guys, then bye bye, each and everyone. Take care. Bye.